When we envision intelligent alien life and how the Milky Way may have other examples of it, it's often in the terms of galaxy-spanning supercivilizations that maintain a presence everywhere, or a galaxy carved up among different empires with little left that isn't claimed. Earth being a noteworthy example of a planet that so far as we know, no aliens have ever claimed. That would be quite a wake-up call if they ever did. Many models of the expansion of a spacefaring civilization show that eventually it gets everywhere in the galaxy if something doesn't check it. But what often isn't talked about is the idea that maybe alien civilizations do not colonize their entire galaxy, but only a part of it, until what they have suits whatever needs caused them to strike out into the cosmos in the first place. Indeed, the idea of claiming every bit of land on Earth is actually a very human thing. The animals can be territorial, of course, but there is no guarantee that an alien civilization would start claiming star systems just to claim them, as humans have done with pieces of land that hold little in the way of economic use. This might lead to an interesting solution to the Fermi paradox in that a partly settled galaxy actually presents a way for aliens to exist in abundance in this galaxy. But the reason we don't see them is that we're simply in the wrong part of the galaxy to do so. Huge swaths of the other side of the Milky Way are blocked by intervening dust and gas in the galactic plane. But more, there is only a certain distance where you can expect a radio signal or optical signal to be detectable. Indeed, SETI does not expect a signal to be distant. Rather, for us to see it at all, it's probably going to be close. So what we can see of the other side of the galaxy is simply too distant to detect much in the way of technosignatures, even if they are there and are loud. They are still unlikely to be loud enough for us to pick up at such great distance. Another scenario here would be if this early in the galaxy's history, no one has yet had enough time to fully colonize the galaxy. We are in this boat. We haven't yet colonized our own solar system, much less any others. If we do go interstellar, there will be a long period, possibly millions of years, where our colonization of the Milky Way is incomplete, meaning that an alien civilization on the other side of the Milky Way may not have had enough time to colonize anything close enough for us to see. But in the future, we will see them as they expand into our view. There is also the question of the speed of expansion, where they may intend to colonize everything, but also realize that they have as much time as they need, so there is no reason to be in a hurry. As an aside, it's hard to imagine what humanity's reaction would be to seeing an expanding civilization colonizing worlds progressively closer and closer to Earth. Granted that space colonization at sublight speed is a very slow process, we would have an enormous amount of time to plan and prepare for the eventual arrival of the alien star empire. If the aliens, when they arrive, find us here, they may leave us alone and continue on. But if they find a humanity that is armed to the teeth, a war could break out. Given that the alien civilization obviously has very advanced technology to do what it's doing, this may not go well for humans. All of these scenarios lead to a partly colonized galaxy, but there is an interesting aside here. Right now, even if we magically developed faster than light interstellar travel and could colonize the galaxy, we have a physical hard limit on what we can do. We have about 8.3 billion people living on planet Earth. The Milky Way, by comparison, has at least 100 billion stars, probably significantly more. And there just isn't enough of us to cover them all, even if every human got their own star system. It may be that no one ever develops populations large enough to actually fully colonize a galaxy, and no one does it anywhere. This might even mean that there are no fully colonized galaxies in the universe. Granted, a colony can take the form of an automated presence like a von Neumann probe, and you can increase birth rates if you want to, but maybe not to the level where it would be viable to completely occupy the Milky Way with a human presence. This idea was advanced by Frank and colleagues, that alien civilizations may develop steady states of expansion, where they reach a stability in their rate of expansion, which leads them to neither collapse nor aggressively spread out into the galaxy, but a more subdued, slower process. It has also been noted that a galaxy-spanning empire that agrees to expand probably requires it to be monolithic. Humans are not monolithic, we don't agree on everything. and not all of us will want a star empire should that ever become viable. That's a big if, however. It may never be viable. You can think of a scenario where the nearest star systems have no suitable planets for colonization, and the distance to the next suitable habitable world is simply too far, meaning that you can get bottled in. But one much easier way of creating colonies works on very long timelines, but it's the most viable. It's the colonization of stars that happen to be passing by in stellar encounters. Many thousands of star systems have passed near Earth in the past, and many more will in the future, meaning that we may colonize not by crossing space, but by letting other star systems come to us. This would lead to a galactic colonization process that would take tens to hundreds of millions of years, or even longer, to fully occupy the galaxy, and maybe no one has had enough time to do this in the Milky Way. This would lead to a very odd pattern of expansion, but at the same time a very doable one. Interestingly, work by Frank and Wright and colleagues varied the factors of a model to look at settlement lifespans, fractions of planets suitable for colonies, and launch times, and they found that in a number of their simulations, they ended up with a galaxy that was only partly settled indefinitely. This modeling was interesting because it actually calls into question another Fermi paradox solution known as the Hart-Tipler conjecture. This idea assumes the absence of von Neumann probes in the solar system. I don't think we can make that determination yet. There may well be such probes in this system, and finding them could be like looking for a needle in a haystack. But if none are ever found, the idea goes that assuming a colonization speed of 1/10 the speed of light, and new probes were constantly created upon reaching their destinations, the calculation was that in about 650,000 years, you could in principle colonize the entire galaxy, a variation of von Neumann's suggestion it could be done in a few million years at comfortable speeds. Since that hasn't happened, then in the conjecture it must mean that intelligent aliens do not exist in this galaxy. Sitting at the heart of this is the Fermi paradox, which is the seeming conflict between the probability of other civilizations seeming quite high, yet there is no obvious evidence of it. This conjecture simply states that at its most basic, that those estimates on probability are wrong. There are many wrenches that can be thrown in the conjecture's gears, however. It could be situational, or we simply don't know how to search for aliens, and so on. But a partially colonized galaxy is yet another. If they exist too distantly, you cannot expect to see them. One area here that is rarely mentioned that can be brought up as to why colonization of the von Neumann probe type doesn't appear to have happened is a simple fact that it may be extremely difficult to build a self-replicating machine. The idea of a probe is simple. It's a probe that uses local materials to make a copy of itself, and then they move to other star systems and rinse and repeat in an exponential manner. However, think about everything that goes into making a machine. You have to mine the metals and materials, you have to process them, then you have to go through all the steps required in manufacturing and programming until you have a copy. Then you have to fuel it, which means even more steps. This is not impossible. We do all those steps in our own manufacturing, but to have one single machine that can do all of it is starting to stretch any realistic approaches, and chances are you will end up with a very large probe to fit everything in. And that's just for the self-replication. There is also what the purpose the probe is intended for, which adds even more. And there's something here that complicates it even further. The universe is 13.8 billion years old, and a large chunk of it, at least the last 7 billion years, some estimates even more, has been able to produce civilizations on planets. It took Earth 4.5 billion years to reach us, but this could have happened even earlier. The problem is that special relativity has a trick in it: length contraction and time dilation. This means that a von Neumann probe could cross a large section of the observable universe within a human lifetime in its frame of reference. It leaves its planet, goes to high relativistic speeds, and then reaches a distant galaxy in a time that it would measure as, say, 80 years. The problem is that when it reaches its destination and stops, it changes frames of reference and finds itself in the distant, far future from the time that it left. This would matter to a human, but a machine maybe not. So the question here is, in the absence of von Neumann probe evidence in the solar system, well, Where are the intergalactic ones? We simply see nothing. Granted, getting up to high relativistic speed is expensive and energy and comes with a host of its own problems, but physics does allow it. That means it also allows intergalactic colonization if you don't care about the passage of time. Yet, all we see is the Great Silence. But in the end, large-scale colonization of entire galaxies or even groups of galaxies is expensive in resources and energy in general, no matter what you do. And it may simply be that you make do with what you need, part of a galaxy. And if you have two civilizations in a galaxy that go to space, if they can't realistically see each other, then it would result in a Great Silence, at least until enough time and spreading has happened that they finally get close enough to see each other, if that ever happens. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently rather spooked. One of the not very often said realities of the Fermi paradox and alien life in general is that there are just too many ins for alien life to be in the solar system. The argument that the distances are just too far don't really account for a machine crossing space. It's not that big of a deal for a machine that can live for millions of years, leading to a reality that we should expect to see alien life here. But there is no convincing evidence of that, and that makes things spooky because it's highly unlikely to be alone in the universe, and the worst possible solution to the Fermi paradox starts looking like the most likely one, and it is the zoo hypothesis. Not good. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.